Hi guys, and welcome to another video. We're going to be looking at the fundamental counting principle, and in this particular video we're going to be looking at when items must stay together. And the question that we're going to be looking at is from the February-March 2013 paper 3, and it reads as follows. Consider the word product. How many different arrangements are possible if all the letters are used? Now the question says how many different arrangements are possible if all the letters are used. So let's look at how many letters we have in the word product. So we've got 1, 2, 3, 4, 5, 6, 7. So therefore the number of items that are to be arranged is 7. The number of items to be arranged is 7. And the number of places that we are going to have to arrange them in, well, will also be 7. Because the question says how many different arrangements are possible if all the letters are used. Therefore, to answer this particular question, can use factorial notation. What is factorial notation? Or the factorial of a number. Factorial of a number is the product of positive integers less than or equal to n, where n is a natural number. So therefore the answer to this question will be 7 factorial, which is equal to 7 factorial equals to 5040. So the answer is 5040. Alternatively, could answer the question like this, where we know that we're going to have 7 places because product has 7 letters. So 1, 2, 3, 4, 5, 6, 7. Will be 7 times 6 times 5 times 4 times 3 times 2 times 1. And the thinking behind it is, in the first position you have 7 letters to choose from, and after you choose that letter you cannot choose it again because it's different arrangements. So therefore the number of letters will decrease by 1 each time, which would lead to factorial notation. So when you multiply 7 times 6 times 5 times 4 times 3 times 2 times 1, you would still get the answer 7 factorial, which is 5040. Let's look at the next question. How many different arrangements can be made if the first letter is T and the fifth letter is C? So 5.2. So let's draw our 7 positions. 1, 2, 3, 4, 5, 6, 7. Now they're saying that the first letter is T. So if you choose T, that means no other letter can go in the first position. And the fifth letter is C. So 1, 2, 3, 4, 5. So therefore, in the fifth position, you can only have one letter, which is C. It's also important to note how many letter T's and C's are there in product. Well, there's only 1. So therefore 1 and 1. So how many letters do we have left? We've got 1, 2, 3, 4, 5. Therefore the 5 other letters can be arranged in 5 factorial different ways. So therefore the answer will be 5 factorial, which is equal to 5 factorial, and that's equal to 120. So therefore 120 different ways if the first letter is T and the fifth letter is C. How many different arrangements can be made if the letters R, O and D must follow each other in any order? Now this leads us to the purpose of today's video, which is how to answer a question where items must stay together. So they say that R, O and D must follow each other, which means that the letters R, O and D must stay together. So let's look, how do we answer a question like that? So for 5.3, I'm going to write down the word product to illustrate to you. So P-R-O-D-U-C-T. So they tell us that the letters R, O and D must stay together. So therefore R, O and D will be treated as one group. and the letters R, O, D can be arranged in 3 factorial different ways. Now this R, O, D would stay together, therefore we would count it as 1. And therefore the other letters, we can count them as 2, 3, 4, 5. Therefore, once again, R, O, D can be arranged in 3 factorial different ways times this one group, and the remaining letters will give us 1, 2, 3, 4, 5. So that will be 3 factorial times 5 factorial. Let's see what the answer is. 3 factorial times 5 factorial equals to 720 different ways. Once again, learners, if you haven't subscribed, please do subscribe to JL Maths, and also catch all the videos on jlmaths.com. And I'll catch you in the next video.